All right, tonight what we're going to be learning about is the Gay-Lussac gas law. And the Gay-Lussac gas law deals with the two variables of temperature and pressure. If those two are your variables, then the other things that can change a gas's behavior is moles, so that means that moles are constant, or N, and that volume is constant, so V is constant throughout. So the only two things that are changing for Gay-Lussac's law is temperature and pressure. What is the relationship between temperature and pressure? Well, as your temperature goes up, your pressure goes up of that gas. Therefore, that is a direct relationship, which would give a graph looking like this. And the formula for Gay-Lussac's law and the direct relationship would be P1 over T1 equals P2 over T2. So a real life example would be putting an aerosol can into a fire. So if you think of an aerosol can, your volume is the same. Why is it the same? Because you are in a steel container or an aluminum container or something like that. So it is always going to stay the same. Okay, if you think about N is going to be the same, which is your amount of moles, because you're not allowing any of the gas to leave, you're not adding any gas into the aerosol can, so that's going to be the same. So what are you changing? Well, if you throw it into a fire, okay, here's my fire. If you throw it in, what's going to happen? Well, the temperature is going to skyrocket because the fire is obviously hot. So if the temperature goes up, what happens is these molecules are going to be moving faster and faster and faster, and they're going to be bouncing off the wall more and more often, which means your pressure is going to go up. And if your pressure gets too high, what you can do is cause an explosion. So I would highly recommend not ever putting an aerosol can into a fire, okay? But if your temperature went up, your pressure went up. All right, let's try to do a practice problem. So let's read the problem and then try to figure out why this is a Gay-Lussac law and how to deal with it. So we've got 5 liters of a gas. So this looks like a V to me of some sort. It's collected at 22 degrees Celsius. So there's my T. And at 745 millimeters mercury. Here's my P. And these both go together, that T and that P. What would be the required temperature? So I know I'm going to have to change it into, I'm going to have to find temperature to change the pressure to standard pressure. So by me telling you standard pressure, I am telling you it's pressure. So if I look at all my variables, what do I notice? I notice I have 2 T's, I have 2 P's, and I only have 1 V. Well, from this, I'm going to assume that my volume is the same. Typically, it'll say it's like in a steel container or a closed container, which means that you can't add any moles, but the volume won't change also. In this one, it doesn't say that, but because there is no other volume, and I know I have to solve for temperature, I'm going to assume that volume is a constant, so I'm not going to have to worry about it. So now what we need to do is put it into our formula of P1 over T1 equals P2 over T2. So my P in this case is 745 millimeters mercury. And I can keep it in millimeters mercury because as long as I have millimeters mercury on the other side. My temperature, I have to add 273 because I always have to be in Kelvin, is 295 Kelvin. That is equal to my pressure, standard pressure, millimeters of mercury is 760 millimeters of mercury. And I am trying to solve for my temperature. So when I cross multiply, I get my temperature to be 301 Kelvin. But it asks for Celsius, so I'm going to have to take off 273, and so I get 28 degrees Celsius with sig figs. Now, a lot of students are like, well, why can't we just do it right away? Well, it's because this is additive, okay, because I'm adding and subtracting my 273, and this right down here is multiplication and division. So those are totally 2 different things. So that is why you need to add and then subtract it at the end, because in between you are doing multiplication. All right, hopefully you have a solid understanding of the Gay-Lussac law, which once again deals with temperature and pressure. Have a great evening.